Hey, good morning. Yeah, the research has been done and the results are in. If you remember, I brought you the story about that 12-pound ice chunk that fell through Ken Millerman's home in Elk Mound back in May. Well, shortly after, we went to UW Eau Claire's chemistry department to try and figure out what exactly is this thing. They had many theories on what the massive ice chunk was, and while they've answered most of the questions, there's still just a little bit of a mystery. I went back to the university's chemistry lab to see what they found.
And we got some really interesting results. But I think the first and foremost result is it's clear that it's not a poop ball leaking out of a bathroom on an airplane.
Back in May, this 12-pound chunk of ice crashed through Ken Millerman's bedroom ceiling.
And it hit you?
It grazed me.
Once the dust settled, UWEC chemists took what they are calling a mega cryometeor back to the lab with a lot of questions.
But the big mystery is how in the world did it get to be this big so that it eventually fell into this gentleman's bedroom?
So Dr. James Bolter and his team tried to answer instead, what is this mega cryometeor made of?
So I was responsible for looking at the biological part of this to see what might be in that ice ball that would be interesting, either alive or maybe preserved.
Maybe this would help us understand where it came from.
We found a really interesting array of microorganisms. Some of them were the so-called blue-green bacteria. Some of them live in Antarctica. They can live in deserts. They've even taken them to outer space. That's how tough these organisms are.
We also saw very low concentrations of metals. The metals we did see were metals like sodium and iron and calcium.
So how do all of these things get into the atmosphere in the first place?
Right, so if we think about the way that ice is formed in the atmosphere, it starts out at the surface, either evaporation of ocean water or fresh water, but a lot of times it has at its nucleus, the center of these little droplets of water or particles of ice, we're going to have a little speck of dust.
That dust may be carried into the higher levels of the atmosphere by strong windstorms at the surface. Dust storms from places like the African deserts, volcanic eruptions in Spain, or even the wildfire smoke from out west. They all eject particles up into the atmosphere.
That's a good description of how droplets form in the atmosphere. Any of those processes form this little chunk of matter onto which the water can condense to form a raindrop or a snowflake or an ice particle. It's hard to know because it's still mysterious in that respect.
But there is one thing Dr. Bolter can say with almost 100% certainty.
The highest concentration metals we measured were sort of in their tens of parts per million. And so that means probably 99.99 at least % water. That's pretty clean.
And this is probably one of those once-in-a-lifetime opportunities, would you say?
Hopefully.
Hopefully for his and Ken Millerman's sake.
And scientists' work is never done when it comes to studying something as rare as this chunk of ice. But Dr. Bolter told me the university is excited to be at the center of this operation. He says this is certainly the most analysis done on any cryometeor within the literature.